let's build off of the SSD calculation to depth and a different normalization, and let's talk about wedge factors and using wedge factors and hard wedges in our MU calculation. From our previous example where we started off with a PA spine field delivering 200 centigrade at the 100% isodose line at a standard SSD of 100, 5 centimeter depth for a 10 by 10 field, we calculated 233 monitor units. We went back and said, well, now the doc wants to normalize 5% down, so he wants to normalize to the 95% isodose line for increased target coverage. Our monitor units changed to 245 MU. Well, now, based on the treatment plan, the dosimetrist needs to insert a wedge into the field. So let's say we insert a 30-degree wedge into our treatment field. Maybe it's the slope of the patient's surface that we need to account for. This wedge, if it's a hard wedge, it's made out of metal. Okay? The metal attenuates the beam. We need to account for that attenuation by inserting a wedge factor into our monitor unit equation. So remember, MU is going to be dose, collimator scatter factor, phantom scatter factor, percent depth dose is our depth component, isodose line. We don't have to worry about an inverse square factor since we're at a standard SSD, but we will put a wedge factor in there for the attenuation of the beam by the wedge. I'm still at a 10 by 10 field size, so my collimator scatter factor is 1, my phantom scatter factor is 1. My depth component, technically the percent depth dose is affected by inserting a wedge. The wedge hardens the beam, which means that it increases the penetrating ability of the beam, which is going to change the percent depth dose. Treatment planning systems account for this, and even some second check software such as RadCalc or MUcheck can account for this. However, with basic hand calcs, most physicists don't print out specific percent depth dose tables for different wedges. So in this example, we will assume that the percent depth dose doesn't change based on beam hardening. My isodose line is 0.95. I'm still prescribed at the 95% isodose line. And now my wedge factor, if I pull out my beam data tables, here I have my upper wedge set. I look at 30 upper wedge. I go across to find my blocked equivalent square is 10 centimeters, which means that my wedge factor is 0.551. Take 200 divided by 0.858 times 0.95 times 0.551. 445 monitor units. You can see between this example, 245, and this example, 445, I have a dramatic increase in monitor units. The reason is because of this wedge factor, which is almost 50%. So I've almost doubled my monitor units. What happens if the therapists forget to put the wedge? Now I know it with today's modern linear accelerators, the chance of this happening is relatively small. However, it still can happen. So what happens to my dose? What happens to my dose if I forget the wedge? I can take my monitor unit equation and I can rearrange it, and I can say dose equals mu times F sub C S sub P PDD isodose line and wedge factor. Now I want to know what happens to my dose at the calculation point. Okay. I'm prescribing 200 centigrade at the 95% isodose line. which means that my calculation point isn't getting 200 centigrade. My calculation point is getting 200 centigrade divided by 0.95. Okay, so the dose being delivered to this calc point is now 211 centigrade, right? Because 200 centigrade is being delivered to the 95% isodose line. So my dose at that calc point is going to be 445 mu. Collimator scatter factor and phantom scatter factor are both 1. My percent depth dose is still the same. I'm at the same depth, 0.858. Okay. I don't want to include the isodose line percentage in this because I want to know what the percentage, what the dose delivered at the calc point is. If I wanted to know what the dose delivered at the 95% isodose line was, I would include that here. But I want to know what the dose at the calc point is. And then my wedge factor is 1.0 since I forgot my wedge. So I can take 445 times 0.858 and I get 382 centigrade at my calc point.